Let's take a quick look at 3 applications of linear functions. First, we have a cereal company, and if it spends $48,000 on advertising, and keep reading, pause if you need more time to read this. Okay, now that you're done reading it, we need a linear equation, so we need some ordered pairs, and our ordered pairs are going to be the amount of money spent for ads and the number of boxes that are sold. They give us 2 ordered pairs in words, and those ordered pairs are 40,000 and 100,000 boxes of cereal. And then $60,000 in ads yields 200,000 boxes of cereal. To get a linear equation, we first need slope, and we do difference in y's, 200,000 minus 100,000, over the difference in x's. You have to go to the same point first. And when you simplify that, you get 5. So our slope is 5. We're going to use slope is 5 and one of the points. I'm just going to choose the first one. And we use that y minus y naught equals m times x minus x naught. Recall that? And so for the y, we're going to use the 100,000. Slope is 5, x minus, and the x from this, remember, first point, 40,000. Distribute the 5. Add 100,000 to both sides. And there is your linear equation. Let's use that linear equation now. The question is, how much advertising is needed to sell 300,000 boxes? If you recall, X was the amount of money spent on ads, and Y was the number of cereal boxes that were sold. So if we want $300,000, that's our Y, and we have to find the X value that will yield that. So add 100,000 to both sides. Divide both sides by 5, and x equals 80,000. Well, you're not done there. When you have a word problem, you're going to have a sentence answer, except for the previous one where it was asking you for an equation. The equation was your answer. So for this one, they need to spend $80,000 on ads. For the next example, go ahead and pause the video, write this in your notes. When you're ready, hit play again. For this one, we have a rental company, and it's a truck rental, and they need a linear equation for the cost. So it's cost with n as the variable, and we're going to have fixed costs plus variable costs, and that will help us to build our equation. You have 2 different ways to do this. First, let's put in what we do know. We know the fixed costs are $30. We don't know the variable cost yet. They tell you it's $65 to drive 100 miles. Well, if that's $65, we know there's a $30 fee. So that means we're really paying $35 for the 100 miles. Well, if you're paying $35 for the 100 miles, you're really paying 35 cents per mile. That gives us then our equation of C of n equals 30, that's the fixed cost, plus 0.35 times the number of miles that you're going. And that is our linear equation. Now that you have your linear equation, which was C of n equals 0.35n plus 30, we can use that to find out the answer to this question. Bonnie's renting a truck. Her total cost was $110. Total cost was $110.50, so $110.50. They want to know how many miles she went. So we can solve this for n. Go ahead and pause the video, solve it, and then come back and check your answer. Subtract 30 from both sides. Divide both sides by 0.35. And the number of miles is 230. So the answer is Bonnie drove 230 miles. Let's move on to another kind of problem called supply and demand. Before we get started, we have some terminology. So the next several slides have terms for you to write down. Each time a new slide comes up, you should pause the video and write it down. So please hit pause. Yes, you should write all of this in your notes. Quantity demanded next. Write all of that in your notes. Equilibrium price, all of this. And now we're ready to do a problem. Okay. We've got two functions. They're telling us that they're giving us quantity supplied, that's S here, P is price. Quantity demanded, that's P is price, D demanded. And let's go ahead and graph these two functions. The x-axis is P for price, and the y-axis is quantity. And take the first for supply, it's negative 200. S of P. And then the demand function has an intercept of 1,000. They're at 1,000. And here where they meet, this is the equilibrium price. Sorry. This is the equilibrium point. I did say price, didn't I? It should be equilibrium point, which includes the price and quantity, which we will get to when we find it. We want to find the equilibrium price and quantity algebraically. To do that, we're just going to set those two equations equal to each other. So negative 200 plus 50p equals 1,000 minus 25p. Let's add 25p to both sides. And let's add 200 to both sides. When you do that, you get 75p equals 1,200. Divide both sides by 75, and p equals 16. So the equilibrium price is $16. We want the quantity, equilibrium quantity. To find that, we go back to either equation that we were given, and we substitute that 16 in. And when you do that, you get 600. So the equilibrium quantity is 600. That gives us the ordered pair, 16, 600. You can do this on your calculator. I'd like you to pause the video and write all these steps down so you have them in your notes. The idea is to go ahead and enter these two functions into y1 and y2 and move your cursor so it's close to the intersection points. You have to make sure you can see it in the viewing window. These first three steps are very similar to finding the max and min of a function. And then the next part, enter, enter, enter. This is because it's asking you for one curve asking you for the other, and then asking you to guess, and your calculator will automatically jump from one to the other. When it gives you the answer, it's going to say intersection, and it's going to give you these two values, and that's exactly what we found when we did it algebraically. Now there's another kind of question they can ask. So very quickly, go ahead and sketch your two curves again. And what they are asking, hit pause if you need more time for that. They're asking you for which quantity demanded is higher than quantity supplied, and decide what prices that occurs for. So they're asking what prices here, what prices along this x-axis is the demand function higher or greater than the supply function. Well, over here the demand function is lower than the supply function, but over here the demand function is higher. So we are looking for all the P prices that give you this. That is going to occur from 0 to 16. Remember, this point was 16,600, the equilibrium point. Now, we have to write this in words. And when we write this in words, we need to say from 0 to 16. Anything over here to the left-hand side of the y-axis makes no sense because those are negative prices, and you're not going to sell something for a negative price. In other words, you're not going to pay people to take what you have to sell. And so they're asking you for what prices the quantity demanded is higher than the quantity supplied. And that's going to happen when the price is less than $16, and you can put comma, but greater than 0. So that's it. Please remember to bring these notes with you to class. Don't forget your graphing calculator.